Three, two, one. What's going on, guys? Welcome to the show. This is the very first episode of the show where every Sunday I try and record a kind of, like a podcasty sort of a format. Sometimes it'll be just me, sometimes it'll be other developers, sometimes it'll be just other people in general. But essentially it's just meant to be like a really casual format, not really a discussion, but just more of a like soft skills focus, not really a programming tutorial or a security tutorial or, some kind of like hard skill. And so on today's episode, we're going to be looking at career pathways for the modern developer. And the reason that I chose this topic is I think there's a lot of discussion, especially, after the fact that boot camps are now a massive thing and, people are starting to question things like academia, and like what is the best pathway to becoming a software engineer or some kind of IT professional. And there's just so many different ways into the industry. And I want to stress this, like just before we even go into this, I guess today's a presentation. There are just so many different ways into the industry. There are so many ways of doing things, and you really shouldn't take this as like gospel truth. In my experience and in my opinion, this is the most standard way that people do things, but obviously there's a lot of standard deviations from the middle kind of. So I just really wanted to stress that point because I know I'm going to get a lot of like people in the comments being like, well, I didn't do it like that, or I did it like this, or, and I fully understand that. And that's great that worked for you, right? And I'll try and mention some of those throughout the course of this presentation. But I just wanted to go through the standard, like if you have absolutely no idea how to break into the industry, and you're really looking to get a head start and you're wanting some advice from someone who's been in the industry a long time, I thought I would do that kind of presentation because I deliver tutorials and that's great, but I know a lot of you want to make money in the software industry and maybe that's one of your key motivators for getting into software. And I'm sure you also love building software, but you want a career in it, you want to make a decent living and a decent wage. And so I really wanted to sort of unpack this beast that is the software industry and try and explain to you how you might go from, knowing absolutely no code whatsoever to basically, becoming the chief technology officer of a company. And hopefully that is what this presentation covers. So let's see. OBS, cool. Now, as I just mentioned, this is a fairly casual format. So I'm not going to be doing too much post or anything like that. It's just going to be whatever comes out of my mouth. And if it's weird, that's fine, whatever. And hopefully I get better at these presentations too along the way, but I'm not really stressed about them. It's kind of a way I can relax too. So let me flip over to my presentation. So today's episode is career pathways for the modern developer. And this is really, I think, something they don't teach you in school, whether that's college or high school or certainly in boot camps. They give you maybe if you're lucky, they'll give you this brief overview of what the software industry might look like for you in your lifetime. And it's going to be different in everyone's lifetime. It's certainly different than, some of the people that are just exiting the industry now versus, my time in the industry versus, future generations in this industry. But I'm fairly confident that this industry will always be around and the kinds of work that we do will certainly change over time. For example, we're doing very little in the way of like systems engineering or low-level development. There's very few assembly developers left anymore, whether that's, Intel, i86 or whatever it is, right? Like there's just very few of us left. And that's okay because we've essentially evolved over time, but that's going to be kind of part of this series, part of this, discussion today, but it's not the focus. So let's just like dive right in. So this, as I stressed at the very start of this, little discussion is, this is the cookie cutter pathway. And I'm hoping that it doesn't automatically skip through here for me. Let's see. I will cut those kinds of things out because they're just annoying to watch. So as I mentioned before, this is the cookie cutter pathway. So it is by no means the only pathway that you can follow, and it's by no means the only roles that exist within the software industry. It's far from it, in fact. But this is the standard, like if you go into any company or any major company or any major organization, you're likely to find some very close variation of this. And there's really a reason for that. It's basically because a lot of these roles, unlike a lot of other industries, are directly tied into the skill set that you possess. And so, like, the more you level up, and the whole premise of today's discussion is the more you level up your skills, the higher you are going to progress in the software world and the software food chain, because the more desirable you're going to become. So basically, like, where do we start and where do we end? And the end is a very ambiguous, vague definition. Like, what is the end? So I can't do an infinite presentation. So essentially, I've capped that at the CTO, but it's by no means like the last place you could go. And for a lot of people, this ends up going full circle, myself included, where you go from stage 0 to stage 6. In a certain company, and then you find a company that's doing way more challenging, work and technology and all that sort of stuff, and you basically end up at stage 0 again, more or less. I mean, it varies over time through your career, but essentially you will at some point go at least semicircle, right? And you may not necessarily go full circle, but you'll go semicircle. So, if you end up CTO at one company, you're probably not going to join the next company as their CTO. You might, but you probably won't. You'll probably be put on as a senior staffer, right? So you'll probably be senior engineer or senior team lead, or if it's something just absolutely brand new, like let's say I'm transitioning into quantum programming, right? Like let's say I'm looking at Microsoft Q#. I might only be able to join as a mid-level engineer. I might be a junior engineer after 15 years of being a software engineer, right? Because it's just a totally different concept, right? I don't know much about quantum physics. I don't know much about, quantum programming and qubits and all that sort of stuff. And so I probably only have a very junior understanding of it all. And so I have to go back up that knowledge tree to get back up to the very top. So the stages that you probably will take within the cookie cutter pathway are stage 0 would be before you get a job. I'm considering that stage 0. So education, right? Getting the skills to pay those bills. So, deciding on whether you want to teach yourself from YouTube or, lots of online resources, whether you want to take a 4-year computer science degree from an academic institution, or whether maybe you want to do a code boot camp. And we'll discuss in detail all of the positives and negatives of each one of those. I should start this presentation by saying that explaining my pathway into the software industry. So my pathway in terms of stage 0, I started programming when I was 5 years old. So obviously I couldn't join any academic or institutions or boot camps at that age. I had a little bit of help from a family member, but I ultimately just really, really loved it, and I started programming from that age, and I became obsessed with it, and every day of my life since then, I was basically writing code, so many years. And then after high school, I did software development in high school, but again, I wouldn't really consider that to be worth anything. It was pretty garbage. And after high school, I already had a job as a software developer. I went to university anyway, and I ended up dropping out of that university course, because it was just not at the level that I was at. I really wanted to push the boundaries of my knowledge, and the university course at a bachelor's level, it wasn't for me. And that doesn't apply to everybody, but we'll go into some of the reasons why I think a bachelor's degree, at least in Australia where I'm from, is pretty half-assed in terms of what they're actually delivering. And so I ended up basically just doing the professional career path, professional development, learning in the industry. And as any experienced software developer will tell you, you actually really only start learning once you get your first job. So then you basically go to stage 1, which is an internship / your first job. And this is basically, and I want to define the scope of an internship / your first job. When I bring on an intern, or when I've been an intern myself, you're really not expected to know anything, right? You're not really, you might need to know how to do a hello world and just some really basic stuff, right? Like really, really basic. Maybe you know one language like PHP, maybe it's JavaScript, maybe if you're, a freak, it's C++ or something like that. But the scope of your knowledge is really quite limited. And because of this, the reason that you're going to the company isn't to be some, crash hot software engineer. It's really just to learn, to get your foot into the door. So, and we're going to go over like everything about this in the next, set of slides, but that's essentially stage one. Then you got stage two, right? So junior engineer. So in the junior engineer stage, and again, we're going to cover this in detail, but the junior engineer stage is just like, I just got my foot in the door. It's my first job, it's probably fairly underpaid. And we'll explain that whole misconception. I know I've seen a lot of YouTubers, especially software developers, complaining about this stage. And I'll explain why that's probably the case. Then you've got the mid-level engineer, and the mid-level engineer is really like the meat and potatoes of your career. It's where you're going to spend most likely the most amount of time of your career. It's going to be at least a 2 to 3 year time window within that bracket there of mid-level engineer. And then at some point you're going to break out and you're going to work your way into a senior engineering / senior staffer role. And in this area, you're really going to start flourishing. You're really going to start to distinguish yourself from the pack. Because I want to kind of like clear up this misconception out there that there isn't enough software developers, that there isn't enough coders. Absolutely not true. There are millions and millions and millions of programmers in this world. There are very few good ones. And there are very few people that make it to this senior staffer position, in the true, most unbiased sense of the word, of being a senior software engineer. And we'll go over what some of the prerequisites I think you require to be a senior engineer, versus I guess what the industry is having to accept more often than not. Then you go into senior team lead, and this role really usually only exists within medium to large to enterprise companies. So, you're going to be basically managing the senior staffers, and all of the developers within a team, right? And you're going to be really in charge of making sure that team's on track. And then finally, you may end up, if you do a really good job at a specific company for a long enough period of time, you may end up as the chief technology officer. So this is one career pathway that you can take. And there are many, right? Like some people may go from being a mid-level to the CTO. It's not likely. You may have somehow leveled up your skills massively, or you may have just been a mid-level engineer way too long, right? You've gotten to that stage skill-wise, and you've been doing that role. But anyway, so there's a lot of different factors, but let's just jump right into stage 0. All right, so let's do a deep dive into stage 0. And it's actually probably the hardest part of your entire CS career. So what are some of the ways that we can look at getting skilled up? So the first one and the most obvious one to a lot of people is university or college, right? And so you could do a 4-year degree in computer science. You could do a 4-year degree in, IT. I mean, around the world, it's all different, right? Like you might be able to do a bachelor's degree in software engineering, some sort of like technical course which has some kind of software engineering element, those kinds of things, right? So some of the things that you'll learn in university or college is some basic CS theory, some basic programming skills, definitely mathematics. And with mathematics, I would say that the one major benefit to doing a university / college degree is the mathematics component. So in college or university, you will have the opportunity to learn discrete mathematics and to learn the mathematics that pertain to things like set theory and, writing, say Alexa, writing a parser, writing these kinds of things. And you will generally end up with a more rounded knowledge of the mathematics that, power computer science. If you do a university or college degree, you will generally not realize that you're even missing these skills if you don't go through a college or university stream. And it's not to say that everybody misses out on these things, and especially now with the advent of better alternative methods of learning this kind of stuff, you may end up with that set of skills, but generally speaking, from my experience, that is a fundamental gap in a lot of people's knowledge. You will do some project management. However, this usually ends up in a debacle because it's very poorly taught. The reason that it's very poorly taught is because it is its own degree, it is its own set of skills, it is its own role in industry, right? A project manager is a project manager. A project manager is not a software engineer, right? And a software engineer may become a project manager, but that is a whole separate set of skills that that person must learn and be trained in order to be a proficient and effective project manager. And the other thing with college and university is that it basically teaches you how not to do teamwork to make the dream work. What I mean by that is, from my own experience and most people's experience within college and university, their way of facilitating, teamwork and learning to do teamwork within a software project is these group projects. Now, because I think that it is still a very immature environment, university and college, it really often what ends up happening is one single person ends up with the majority of the workload. And on top of that, it doesn't really show you how to use things like Jira, Confluence, Monday.com, or any of these other project management tools. It doesn't really teach you how to collaborate. It just asks of you that you collaborate, which is a very poor implementation of a very important soft skill. So university or college, definitely one of the ways you can get into this. So about university or college, it's not for everybody. It certainly wasn't for me. I definitely found myself very disgruntled with university and college. I found that the course material itself was very, very weak, and I will get to that in a little bit. But the university's course material, minus the mathematics, was very, very weak. Very, very, very basic. And I don't know if this is just an Australian thing, but for sure my university degree was just abysmal. And it's the same whichever university you go to in Australia. They're all pretty much just atrocious. They don't really teach you. And the main problem, I guess, with university and college is it does a very poor job for the amount of money that you spend on it. It does a very poor job of preparing you for industry. The next one is DIY self-taught online tutorials or whatever else is out there, right? So this method really will help you develop strong problem-solving skills. The reason that it's going to help you develop some strong problem-solving skills is that there really isn't any other way to do it, right? If you're doing the DIY method, you're going to run into problem after problem after problem after problem in terms of, for example, you're going to have compiler errors, you're going to have, tooling errors, you're going to have all sorts of problems, right? And there's going to be no one else around to really help you with those problems. The next thing that DIY will teach you is obviously some computer programming skills. So, generally with a DIY track, you start with an idea like I want to build a mobile game, or I want to build a whatever it is, right? If you want to build something. So you go ahead and you look about the internet, or you look about books or whatever it is, right? Like whatever your source material is. You go ahead and you look around and you start building, right? And so you really start getting your hands on code from day one. And the reason I put an asterisk there is because you will basically only learn what is needed for the projects that you are doing. So if you're going to go and follow the DIY track, which is totally fine, right? Then I would highly recommend you to pick a very large array of different kinds of projects. So maybe you build a mobile game one week, then the next week you build a desktop application, then you build a web application, then you build a server-side application, maybe then you build some drivers, whatever it is, right? But it's really important to get your hands onto as many different languages, as many different frameworks, as many different technologies, as many different concepts. You will certainly learn no project management through the DIY method. And this may or may not be a good or a bad thing. It certainly allows you to focus way more on the deeper side of the technology stacks that you may be interested in, because you're not really worried about collaborating with other people. And any collaboration that you do will be at a very rudimentary level. It's actually probably the most real-world methodology of learning software and learning IT in general. And the reason that I say this is because much like in industry and day-to-day work in industry, you're going to face a lot of challenges. And the quicker you develop your ability to independently solve those problems, the quicker you will become a better software engineer. The final point that I really want to touch on here is that the DIY method really requires a certain frame of mind. The frame of mind that it requires to be successful with the DIY method, and I'm speaking here from a lot of experience of having mostly done the DIY method, is that you really have to be motivated, and you really, really have to love software engineering. You really have to love technology, and you really have to love software, but you also really have to have a break everything, fix everything mindset. Basically the mindset of a traditional white hat hacker. So you really have to be of the mindset that nothing is off limits, and you're going to reverse engineer everything that you come across and really try and understand from the bottom to the top, and then from the top to the bottom how it works. And, you know, with the mindset of like, if I broke it, if I pulled it apart, I'd actually be able to put it back together. It also requires a lot of self-discipline. It also requires a lot of self-motivation. And it generally requires you to have the frame of mind where, you know, no matter how difficult a problem seems or how many hours it's taking you to fix like just one little problem or one error, you're not going to give up on that, because you'll be surprised on how much knowledge you obtain by just solving, you know, what seems like it should be just a really simple thing to fix. But along the way, you obtain a lot of information, a lot of skills, and you will eventually solve that problem. And that's why my personal opinion is that someone who does the DIY method properly, over a long period of time, will probably end up being the most skillful software engineer, right? Skillful software engineer of all of these different kinds of methods. The next one that I really want to talk about is the code boot camps and the alternative education. So firstly, let me define alternative education, because this may not be a thing in your country, but in Australia, where I'm from, we have these things called TAFEs, and for a lot of things, TAFEs are really, really good. However, the problem with these TAFEs is that they generally are very superficial programs. And the problem with that is computer science is not a superficial topic. If you have a superficial understanding of computer science, you really won't be able to break into the industry. So depth of knowledge is super critical. The same problem basically applies to code boot camps. I'm personally not very excited when I see someone that came out of a code boot camp. I'm not biased against them. I have absolutely nothing against code boot camps, and I think that if you want to do one, you should definitely do one. But when you assess the pathway to getting into the industry, you really have to look at the depth of knowledge that you're obtaining. So some of the problems with both of these methods, right, whether it's some private code camp or whether it's a public code boot camp or whatever sort of like, you know, you guys, I think, you know, most of you know what I'm talking about when I say like code boot camp / you know, alternative education being like not the DIY, not being a university. It basically boils down to the following problems. It's very fast paced, right? So usually these code boot camps only last for 3 to 6 months. You really, really can't get that much out of anything in 3 to 6 months. You know, it usually takes thousands of hours just to begin to master a skill, and computer science is such a large topic that you really can't, I don't believe, get that much more out of a code bootcamp than you could get out of the DIY method. The other problem with them is that they're super high level. They generally always focus around web technologies and JavaScript and HTML and those kinds of things. And those are necessary skills, don't get me wrong. But they do not give you an understanding of the fundamentals of computers and computer science, like memory, like CPU architecture, like asynchronous programming, data models, data structures, algorithms and all of these things that, really make up coding, as a lot of these companies would put it. I believe that they are preying, and I really feel like a lot of these code bootcamps are predatory. They really prey on people who are desperate to break into the industry, don't have any skills, probably don't know how to obtain those skills. And I feel like they're fairly predatory, a lot of these code bootcamps. And as a side note, if you're a code bootcamp and you want to debate me on why you're not predatory, or why you think that what you do is better than, other methods of teaching people to code, or teaching people to program, or teaching people to be, outstanding CS citizens, I'd love to have you on the next episode, or whenever you guys want to be on this show. But from what I've seen from, quite literally hundreds of these code bootcamps around the world, most of them seem fairly predatory. They are aimed, and a lot of them make a very bold claim that they will get you into a job. They're aimed at getting you into a job ASAP by sort of padding out your resume, saying like, yeah, this person knows JavaScript, this person knows React, this person knows, whatever it is. They're not really focused on leveling up your understanding of technology. So let me give you an example of what I mean. For someone who may have already done a code bootcamp. In your code bootcamp, if you were lucky, you may have done, async await, right? You may have done promises. But most of these code bootcamps will not focus on the fundamental premise of all of this, which is asynchronous data models, right? The asynchronous data transport, asynchronous data models. And so when you actually become to, start writing asynchronous code, you're not really going to understand things like data races, mutex locks, resource identifiers, all of these really fundamental concepts, and that, although they're not necessarily applicable to, say, JavaScript, having this understanding in the back of your mind, when something goes wrong, even in a high-level language, you will basically be able to pinpoint very quickly, this is what's going on. For example, if it's a data race and you're getting unpredictable behavior between, asynchronous code here and code that is running over here, well, it's pretty obvious to an experienced developer that understands asynchronous programming, hey, this is what's going on, right? Like it's really obvious, right? Sometimes this thing finishes first, sometimes this thing finishes first. Well, to me, that's super obvious, but I have an understanding of asynchronous, programming and asynchronous data in general, and asynchronous operations is probably a better way to put it. So it's easy for me to pinpoint those things, and I feel like code bootcamps, because they're trying to get you into a job really quickly, often miss a lot of that. They usually are focused on web technologies. I already mentioned that. That's okay if you want to be a web developer, but I would highly recommend you to branch out into many different technologies. I would highly recommend you to learn at least one systems language, whether that's Rust, whether that's C, whether that's Go, whatever systems language you want to learn. I would highly recommend you to at least branch out into one of those and get a very solid understanding of that, because that's going to teach you a lot about computer architecture. And a note for both the code bootcamps and, potential future students is, systems languages are actually now coming full circle with technologies like WebAssembly and C++ to WebAssembly and those kinds of things. And so while these code bootcamps have been getting away with very shallow understandings for a long time, the next generation of web developers are probably going to have to know systems languages again, which is super funny to me, because it's been shunned into a corner for the longest period of time. But now we're coming back around with like WebAssembly and stuff. We're really going to have to know these technologies if we're web developers. They usually promise a lot more than they can deliver. What I mean by that is they guarantee you things like jobs, or they'll say you're pretty likely to get a job. The truth be told, as someone myself who is responsible for hiring and doing technical interviews, I very rarely pick up staff or even pass them on to second round interviews from code bootcamps, and it's totally not their fault. They've just been promised way too much and they're applying for the wrong kind of job. But I have been fairly negative about them, but let me give you this. They're usually fairly cheap, right? They're usually maybe $1,000, $2,000. That's the amount of money that you should be spending on a code boot camp. And they're a great introduction. And if you treat them as an introduction to programming, for people who have never seen a line of code, it can be a really fast way to get your hands on some JavaScript, get your hands on some, maybe C#, whatever it is, right? Get your hands on some of this code without investing tons of time and tons of money, right? Because as I mentioned, they're very fast paced. Okay, stage 1, your internship and your first role. You should be under no illusion when you start this process that you're going to be some kind of elite hacker or some kind of like movie star, 5 screens all over the place in green text matrix style, flying everywhere, right? It's just not going to happen, right? You're never going to be the movie star, right? That's not what this is about. This is about solving, sometimes complex mathematical problems or, input-output problems or whatever kind of problems you're solving. But, never in my entire career have I ever seen someone with 6 screens and, and Japanese recipes, which if you love the Matrix, you know what I'm talking about, flying down their screen. So if that's the reason you're getting into this industry, probably pick another industry. But you won't be an elite programmer. You won't be the best. You will probably not be very good at all. And that's okay. You will sit on someone's lap like myself, hopefully not literally sitting on my lap, but you will sit on someone's lap for, days at a time. And you will basically be watching over their shoulder, asking them questions, asking them why they're doing X or why they're doing Y. And hopefully the person that you're watching is a very good programmer and they can help explain things to you and help you to develop your understanding. Internships usually last between 6 and 12 months, and this is very dependent on the industry. If you're going into, say, the games industry where you want to be a game engine developer, an internship might last up to 12 months because the kinds of work that you're doing in the game industry is very complicated. When you compare it to, say, building business applications or desktop applications or that kind of work, it's very different and it's a very complicated sort of an industry. In contrast, for example, the game industry is working on graphics programming with things like Vulkan or OpenGL or DirectX, or those are just behemoth topics in themselves. They're actually working with hardware, like GPUs and GPU memory and those kinds of things. And then you've also got so many different concepts. So your internship is going to last a long time. If you're doing something like biz dev, business development, then you probably will only be doing a 6-month internship because by that time you should be pretty well across whatever technologies that is used within that industry. And there are a lot of other industries I can't speak on, but for example, the medical industry, if you're doing medical programming, your internship may last longer than 12 months. But I don't have any experience in those industries, so I'm not going to comment. One massive thing that I want to stress this to everybody. Do not get taken advantage of in this stage. You are an intern. This is your first role, right? You are going to be getting paid absolutely nothing in this stage, right? Maybe peanuts if you're lucky. And therefore, the amount of work you should be doing in terms of hands-on productiveness for the company is basically peanuts. You shouldn't be doing much at all, right? You should be sitting on someone's desk all the time, learning from them. Maybe you're contributing a little bit of code every second day or every third day, to just further your understanding, taking away from the senior staff that you're working with and trying to implement that yourself. Because as we all know, most of us learn by doing. We don't just learn by osmosis or watching someone. But do not become a full-time developer or a full-time software engineer, because at this point you're being taken advantage of, and a lot of companies are extremely predatory in this way. They will use internships, and a massive shout out to Joshua Fluke for this point, and I 100% agree with him. A lot of companies are predatory and they will use you as cheap labor rather than a true internship. So try and find a reputable company that provides a real internship rather than cheap labor for hire. Okay, the next stage is junior engineer. So this is where me and someone like Joshua Fluke might diverge on our agreements or disagreements, but at the same time, I'm sure we're going to agree on a lot of things too. Getting your first job as a junior engineer is very hard for most people. Not everybody, but for most people, it's very hard. Now, why is it that it's very hard to get your first position? It's been stated before across the internet and, on YouTube and stuff, and I'm not going to call out specific people, but, it's been stated before that the company owes you something, or, some variation of this even when you're a junior developer. The truth of the matter is, you are terrible at programming. You are terrible at technology, and you are terrible at programming, and that's okay. You just finished your education. You don't have any real world experience. And 99% of junior staffers cost the company way more than they actually make in terms of productivity. And this changes over time within the person's career, but 99% of the time you are an expense to the company. So the company has to make a very forward-looking decision on your hire. They have to say to themselves, okay, if we hire this person today as a junior developer, and we invest 6 to 12 months of solid work into that person, through training programs and letting them have hands-on time with real-world projects and et cetera, will they then become a productive member of our organization? That is the question that an organization has to ask themselves. The question that they're not asking themselves is this person going to be productive as a junior engineer on day 1 or day 6 or day 50, right? The answer, they already know the answer to that. The answer is no, you're not going to be that productive. Most companies will treat you like a paperweight because you are a paperweight. You are going to significantly slow down projects. You are going to significantly hinder deadlines. You are an expensive investment. I'll put it that way. And it's mostly accurate that you are a paperweight. But if you've been hired as a junior developer, don't be discouraged. It's because we as senior staffers, or we as an organization, really see you as having a lot of potential. Because just remember, I just said that hiring a junior developer is fairly risky for a company. Being a junior engineer is exhausting. It really is. And I think back to my time as a junior engineer. It is truly the most exhausting part of my career. I would, go to work every day from, 8:30 a.m. and finish at 7 p.m. at night or 6:30 at night. And most of that time was spent learning new things. It was spent, asking a lot of questions. It was spent trying to figure out, how this whole industry works, right? So, 5 days a week, 8:30 to 7, 8:30 to 5, 8:30 to 6, something like that. It's very exhausting. It's very mentally draining, especially when every single day you're just consuming so much new information. However, it is the most rewarding part of your career. It was certainly the most rewarding part of my career. And it's where you will learn faster than you have ever learned before. If you're someone that really, gets a high, really thrives off of the feeling of not understanding something and then understanding it and then achieving something and overcoming a certain hurdle, whether that's like, I couldn't get this window to display and now I can get it to display, or I've never worked with graphics before, but now, I'm building things on top of the Vulkan API or whatever it is, right? It's a very, very, very rewarding part of your career. And I love this phrase, but I feel like even us as senior staffers often end up chasing this dragon of like, and it's something you should be chasing, right? And I know that's a drug reference, but it really is a part of your career where you're constantly getting that high of achieving something new, and it happens nearly every day. And that's such an awesome part of time in your career, and you should really cherish it. The next thing that happens to literally all of us, including myself, is you're blissfully unaware of how the code you write will now be the death of you in a few years. So what I mean by that is, you're a junior staffer, right? You're not an intern, you're actually a junior staffer. That means that most likely you will be around with this company for at least 2 or 3 or 4 years, right? And the code that you write on day 1, which may end up actually in a production system, you will be responsible for the maintenance of it, right? And as you progress and get better as a software engineer, and you have to come back and look at your old code and look at how and maybe perform maintenance on that piece of software, you will realize you will realize how bad the code that you wrote is, and now how stressful it is to go back and fix that. But really, my point with this is, don't be so hard on yourself. We all wrote terrible code. Some of us still write terrible code, like myself. And it's just part of life in the software industry, right? You will write bad code. Don't be too hard on yourself. And some advice I would give to you is, write some notes down on paper, or write some notes down in your note tracking software of what it's supposed to do, and that way you're not reliant on having to reread the code. Obviously, do good practice things like comments and all these kinds of things, especially when you're a junior developer and your code doesn't read like poetry. It probably reads more like some kind of screamo song. It's probably best to put a lot of code comments. Next thing that I want to talk about, and this is kind of personal to me, and I've watched a lot of YouTubers talk about this, and I'm going to call out one specific YouTuber, Joshua Fluke here. He has a very fair assessment of the industry as a whole, but I feel like he may for whatever reason just be pandering to his audience base or whatever it is. Because Josh is a very smart guy, and I have a lot of respect for the man. When you're a junior developer, right, getting $60,000 a year is not stupid, right? It's not unfair. It is not stupid. As I mentioned before, you are a paperweight to the company. Basically, you really, really, really are going to be ball and chain to a senior engineer, to a senior staffer who is going to guide you up Mount Everest like a Sherpa. This is an investment that the company has to make. Now, they have to take a calculated risk, whether you're going to jump ship, whether you're going to be even able to climb Mount Everest, all of these sorts of things. And so they're essentially saying that the risk we are willing to take on you is worth $60,000 or $70,000 or whatever it is, right? And you really aren't worth any more, right? Because in the software industry especially, you are paid based on the amount of skills that you have and the depth of those skills. So unless you're some sort of wicked good junior engineer, which means you probably wouldn't be a junior engineer, $60,000, that sort of ballpark range, even $50,000, is not ridiculous. And you'll see why when I move into stage 3. However, I want to say one thing: you are overworked. You will definitely get overworked, and you should try and stop this at all cost. You are a junior engineer, right? So your your salary expectation is low, but your output expectation should also be very low from the company. And they are looking to ramp it up over time. But as your output ramps up, your salary should ramp up with it. But you are overworked. So you will feel underpaid and overworked. You are overworked. You're definitely not underpaid. Unless you're really, really getting underpaid, right? And it's hard because it's different in every country. But I would say a good starting salary what's a reasonable starting salary when you really have no skills is probably $65,000 a year in, let's say, Australia or in the United States. It can also often feel like you're climbing Mount Everest, the Mount Everest of new tech stacks and languages. As I've mentioned a million times, there's just so many different things to learn, and there really isn't enough time in any day. And so my advice for this is find yourself a Sherpa, whether that's the CTO in a small company or whatever it is, but find someone who can help you and guide you up Mount Everest. All right, I want to talk about getting a job quickly as well. As a junior engineer, build a portfolio on GitHub/Bitbucket. As a senior staffer, I genuinely look at these a lot. If someone sends me with a resume without a GitHub or a Bitbucket or some kind of technical portfolio, I'm very unlikely to proceed to an interview. And if I do proceed to an interview and they still don't have a GitHub/Bitbucket repository, profile, I'm going to ask them to do some homework to just make sure that they really are who they say they are. Now, this one's controversial, and this is coming from myself as a senior staffer. Skip HR. If the company is using a recruiter, find the CTO. If the company doesn't have a CTO, find the senior team leader. If the company is too small for that, find a software engineer at the company. HR/recruiters will generally push you away. They're not looking generally for real junior engineers. Now, here's where me and Josh will always agree. And I don't know why I keep mentioning him, but he has some really, really, really good videos on these topics. So I'm using him as kind of a reference point. And I'm sorry, Josh, if you don't like that, let me know. I won't do it ever again. But HR and recruiters are there to squeeze as much out of you as you can. So they will take even a senior engineer and try to pay them and put them in as a junior engineer. That's not okay. Okay. Now, it is one of the main reasons why you should avoid talking to HR and avoid talking to recruiters at all costs. Is their job isn't to find the best candidate, it's to find the best candidate for the cheapest price. So find the CTO, right? Find someone in the engineering team, because their motives are never actually going to be aligned with HR. They want someone technically apt, and they're not so worried about how much you cost. Find a good work-life balance. Software engineers experience very high burnout rates. I have burned out myself. I went on a hiatus for up to a year, and I went skiing and just had to chill out. If you love video games, please do not stop playing video games, right? You have to find a balance between work, life, and learning. If you do not find this balance of chilling out and learning and working, you'll burn out and you will not be able to do any more work, and you will not be able to do any more learning. As a junior engineer, I believe, and this is different for everybody, but I believe that you should make an hour to 2 hours per day for self-education, trying to learn something new. And if you love video games, maybe you should just try teaching yourself to build video games, right? Just as an example. Take full advantage of the experienced senior staffers around you when you do get a job. You're a junior and you're on junior pay, and it's expected that you are there to learn as much as you are there to work. So just because you are a junior and you're expected to have some level of productivity, because otherwise the business just could never justify hiring you, it is also expected that you as a junior are going to be, learning day in and day out, and you're not going to be producing nearly as much work as a senior staffer, right? And you're not getting paid to do that either. One thing that I do want to talk about is taking code reviews very seriously. It can often seem like someone is attacking you, or attacking, attacking your ego, or attacking your character, or whatever it is. But you really have to know that they're not attacking you and they're not attacking your character. Code reviews should be critical. Code reviews should be not nasty, but very strict and harsh, because it's the only way that you're going to get better. Now, as a junior engineer, as a mid-level engineer, even as a senior engineer, your code probably sucks right now. And especially as a junior engineer, your code probably sucks. And that's okay, right? You're a junior engineer. This is just a start. Get feedback, iterate, and level yourself up. I can't stress that enough. Level up your skills, iterate, continuously learn. Please, guys, iterate your skills, right? Iterate your abilities, iterate your code, iterate everything, level it up, get it better every time. Never be content with what you just did. Even myself, even as a senior staffer, it's one of the things that defines a senior staffer is someone who has the ability to continually not accept the level that they're at and continually push those boundaries. I made this point already quite strongly, but companies are investing in your potential and are not actually making a profit out of you. If a company is making a serious profit out of you as a junior engineer, you may want to seriously consider whether or not you are even a junior engineer in the first place, and whether or not you should be getting paid a lot more. I would argue that you are probably not at a junior level if the company is making a serious profit out of you. Your extra hours are contributing to you getting better, thus being able to earn more. So you will probably do longer hours than a lot of people at your company. Try not to take this as a negative and don't get abused in the process of this. Do it when you want to do it, but the more hours and time you put into a new skill, the better you're going to be at it. Thanks for watching, guys. Unfortunately, I had to cut this episode short as it was getting up into an hour and I just couldn't keep continuously recording on the day. In the next episode, we're going to be covering stage 3, stage 4, and all the other stages that are involved in your CS career. So without further ado, please check the link in the description. I'll update it when the next episode of this is ready to go. Check out all my other tutorials, check out all my other videos. I really appreciate you guys' support. I love you. I hope you're all staying safe, and I will see you next time.